Hey team, this is Year 2 Pure, Chapter 9, Lesson 4, and this is the product rule. So, before you start doing the product rule, you need to be really comfortable with dealing with the chain rule. If you don't really have much confidence dealing with the chain rule, you're going to get a bit more practice during the product rule, but you should also really look back on it, because otherwise this will be quite a difficult task. So, what I'd like you to do is maybe pause this video, try out these questions, and then we'll go through the answer. So, differentiate y equals 3e to the power of 2x plus 1. So what you have is a function e of a function 2x plus 1. And so we'll express y is equal to 3e to the u, where u is equal to 2x plus 1. And to use the chain rule, we'll differentiate y with respect to u, which is going to be 3e to the u, multiplied by differentiate u with respect to x, which is 2, and then we'll substitute back in that we've got u was 2x plus 1, and so we'll end up with dy by dx is equal to 6e to the 2x plus 1. Okay, nice and easy, should be absolutely fine, that one. Alright, moving on. Next we've got a trig question. So again, we've got a function of a function. We've got the function cos applied to a quadratic curve, and so we'll express y as y equals cos of u, where u is equal to 3x squared. So we're going to differentiate y with respect to u, and then we're going to differentiate u with respect to x. Now, differentiating trigonometry, you should know that we've got this ladder. So we've got sine starts, we've got sine cos minus cos, and d is for differentiation, d is for down. So to differentiate cos of u, we're going to get negative sine of u. So we'll get dy by dx is going to equal negative sine of u multiplied by 6x. So we'll get negative 6x sine of u, which was 3x squared. Okay, should be pretty comfortable with that. And next, find the gradient of f of x at the point 125. So in this case, we've got a linear function being raised to the power of 3, and so we're going to express f of x. You can express it as just y, change it straight away to make things a little bit easier. It'll make it easier to understand this bit as well. So I'm just going to call it y instead. And so we'll get y is equal to u cubed, where u is equal to 3x plus 2. Now dy by du, or dy by dx, will go straight to an answer. Dy by du was 3u squared plus 3, multiplied by 3, and so we're going to end up with 9u, which was 3x plus 2 squared. Okay, now we're finding the gradient at the point 125, and so at x equals 1, dy by dx will equal 9 lots of, well, 3 ones of 3 plus 2 is 5 squared, and so you get 9 times by 25, which is 225. Okay, you should be comfortable with those before you can really move on to product rule. So here is a product rule question. It looks quite similar in many respects to the chain rule. You've got functions, you've got multiple functions, but you don't actually have a function of a function. Not fully. You have a function of a function here. That is a function of a function. You've got the root of a linear. But you've also got a multiplication happening between 2x cubed and that function of a function. And whenever you have a function multiplied by another function, two things where one isn't just embedded within the other, whenever you have that, you can use the product rule. Now, using the product rule is dead simple, but you need to be very comfortable with the chain rule. Now, the product rule, if you have dy by dx, it will be equal to u dv by dx plus v du by dx. Now that only works if y is made up of a function u of x multiplied by a function v of x. So when you have those two functions multiplied together, you have one of the functions multiplied by the diff of the other, plus the other function multiplied by the diff of the original. So you have this multiplied by the diff of this, and you have this multiplied by the diff of this. Okay, so the first thing is, now that you've identified that it's a product rule, you should say let u equal 2x cubed, and let v, give yourself plenty of space, equal 2x plus 3 all raised to the power of a half. It's going to be much easier if you don't have that in root form. If you just have it in power form, it's much easier. So you have two functions multiplied together. Just identify what they are. Now, du by dx is an easy one. That's 6x squared. dv by dx involves using the chain rule. So dv by dx will involve, well, if we knew that v was equal to this, then what we could do is we could say, well, v is equal to u to the power of half when, we shouldn't really use u, so we'll use w. V is equal to w to the power of half when w is equal to 2x plus 3. And so dv by dx will equal, well, you'll have a half of w, which is 2x plus 3 raised to the power of negative a half, multiplied by 2. Okay, so diff the outside, diff the inside. You should really by now, and this will equal 2x plus 3 all raised to the power of negative a half, which will like that. You should really by now be able to differentiate stuff like that just without too much working. But if you still need the working, do the working. Okay, so dv by dx is equal to 1 over root of 2x plus 3. Okay, so you can leave that as to the power of negative a half if you really, really want to. That's fine. Now, when we work this next chunk out, we're going to be doing u dv plus v du. If you accidentally do v du plus u dv, it doesn't matter, they're adding up anyway. So we're going to get that f dash of x, the derivative of f of x, is going to be 2x cubed multiplied by 1 over root of 2x plus 3 plus 6x squared multiplied by 2x plus 3 all raised to the power of a half. A bit of tidying up, you'll get 2x cubed over 2x plus the square root of 2x plus 3 plus 6x squared root 2x plus 3. Okay, so not too bad really. It's pretty much okay, but the only difficult part really is probably the chain rule. Alright, let's move on. So here's another question. You might want to pause the video, try it out if you want to, but then we'll go through it. So y is made up of a product, and so we've got u is going to equal e to the 3x, and v is going to equal cos of 3x all squared. Okay, now the different derivative of u with respect to x is pretty easy. That's 3e to the 3x. But dv by dx is going to be a bit more difficult, because what you've got is cos of 3x, and so you should remember from differentiating trig earlier that the differential of the inside, dv by dx, derivative of the inside will be sine cos negative sine negative cos, and so you're going to get negative 3 sine of 3x. Okay, that's the derivative of the inside multiplied by the derivative of the outside, which will be 2 cos of 3x. And so you'll end up with negative 6 sine of 3x cos of 3x. Okay, it's not too bad, it's just that you need to get really, really, really quick with the chain rule. Okay, so once you've got that, the next step is to multiply this by this and this by this. Okay, so you're going to get
The best of the Indie List 2020 from Adam Spotify.
Sorry, an interruption from Alexa there. Right, we've got negative 6 e to the 3x sine of 3x cos of 3x plus we have 3e to the 3x lots of cos squared 3x. Okay, quite a lot of work going on there, quite a lot of things happening, but at the end of it, it's pretty much just number crunching. Right, moving on. Thanks very much for watching. Hopefully that helped. You should work on some of the questions. Thanks.